Okay. All right, here we go. We're going to get started. Okay. All right, sorry about that. All right, give it a second. Just let the noise. Okay. All right, here we go. So sorry about the delayed start here. No, bells were not working. All right, game plan for what's going on. We're going to start the Unit 2 review today. Let's see if I can move this. All right, here we go. Okay, I think this will work here for now. All right, what's going on? Unit 2 test, we're going to review it. And again, not everything you see on a review is going to be on a test. So classes started at this time. Okay, so we need to put away phones, laptop, put them down. Okay, we're starting. So, no, they're not ringing. Classes started. We need eyes and ears all this way. So, what's going to happen? We're going to talk about, for instance, types of angles. So in Unit 2, we started talking about types of angles along with angle relationships, such as, with parallel lines. And then towards the end, we started talking about some types of slopes. So what our goal is for today, really quick, we'll zoom out real quick. So the goal, Unit 2 review, we're going to use the actual test. If there's time, we may start the Unit 3 review, depending on how much time. I hope to complete this with some time to spare, so you can work on your vocabulary project if it's not yet complete. I know some of you may have or just about have completed it. You can use this time to fine-tune it. Again, project is due a week from today, because that's the last time I will see you all this quarter. And you also have a mid-year point test. It's going to be, oh, that should be the 25th for you all. So, fix that real quick. That's 125, not 126 for this class. That will be a quarter 3 grade. You are allowed to make up your own set of notes. Basically, write down important information based on all these review activities that we're going to be doing. You're allowed up no more than 2 pages, though. Yet you will be allowed to use just whatever 1 to 2 pages of notes you make up. That's actually going to be a homework grade. So think about it like this. Major opportunities to start off on a great foot to start off the 3rd quarter. So those are going to be the first 2 grades of the 3rd quarter. Depending on what we cover between now and next week. So Unit 1 review that we did last time, that's a classwork grade. You complete it, you get full credit. complete this activity. Full credit classwork grade as well. We should be able to complete it over the period. We start now. And then we may start Unit 3 review. Let's see where we are time-wise. Because I want to give you all some little bit of time to work on that vocab project. Also, I am available after school today. If I'm not in this room, I may be 2 doors down. More than likely, I think I'll be in here. But if I'm not, I might be in Miss Muse's room, which is 2 doors down from here. All right. We're going to move on. Okay. We're going to start talking about some types of angles, angle relationships, angle measurements, and then relationship between angles that are between parallel lines. That's our goal for the majority of this period. All right. So for the first one, we have angles 4 and 12, or what type of angles? So, again, highlighters are important. If you need a highlighter, they're behind Andy. So if you need one, get one. So 4 and 12, that's where the angles are located. Who remembers, when we look at the intersection, they're in the same spot. 4's in that bottom right corner, 12's in that bottom right corner. So what type of angles would we have in this case? Corresponding, very good, Alex. We're going to be talking about these types of relationships, such as corresponding angles. Corresponding, that means the same spot in the intersection. So corresponding, same spot of the intersection. Bottom right corner, bottom right corner. That's where we are. Okay. And for number 2, there's 4, there's 9. What type of angles are 4 and 9?
Alternate interior.
Alternate interior. They're opposite and inside. Opposite side, inside. Remember, you have outside, inside, and back outside. Opposite, inside. All right, so far, any questions? Okay, what about 10 and 9? There's 9, there's 10. Let me use a highlighter for this. There's 9, there's 10. Who can tell us what we have here? Why is it a linear pair?
Same line.
It's on the same line? Okay. And what else is formed here between these two angles? So with a linear pair, they form a straight line. And then, I know we don't have to worry about it yet, but if they're a linear pair, what would be the sum of the two angle measures? The linear pair.
180.
Very good. We'll sum up to 180. Supplementary. Supplementary means they add up to 180. So, good job. What about 10 and 3? Look where they are. Gotta be careful. They're not quite vertical. There's some.
Are they alternate exterior?
Say it again.
Alternate exterior?
Why?
That's like they're both out.
Mm-hmm. Okay. Alternate exterior.
What was number 4?
When you pair, you need to pay attention. Yeah, alternate exterior. Outside and they're opposite. Alternate exterior. So that was number 5. That's angles 10 and 3. So far, any questions? So the difference between the alternate exterior and a vertical, the vertical, they're at the same intersection. That's why, unlike the vertical, are 10 and 3 located at the same intersection? Look where 3 is, look where 10 is. Are they at the same intersection? No. All right. Questions before we continue? Again, these angle relationships are going to be key because in a little bit we're going to talk about the relationship angle measures. Because that's going to help us determine, we have this angle measure, we can get all the others. What about 11 and 4? Here's 11, there's 4. It's going to tell us what type of angles we have between 11 and 4. Let's look where they are.
Consecutive interior?
Why consecutive interior? You're right.
I was like, they're in the same line and they're both like in.
Okay, they're inside. Same side. Inside, same side. That's why they're consecutive interior. And does anybody remember, if I have consecutive interiors, what would be the sum of these two angles? 990.
180.
Bingo. And they also add up to 180. Well, in most of these cases, they will. Unless if I tell you otherwise. And reason being, since these are parallel lines, it will add up to 180. And in most cases, I think the problems I give you of these type will be parallel lines. So consecutive interiors are 4 and 11. Inside, same side of that, transverse. But what about 1 and 4?
Vertical?
They're going to be vertical. They're opposite and they're at the same intersection. All right, questions up to this point? All right, this one. Given lines K and L are parallel, if they're parallel, and the line T's are transversal, so you got parallel lines, boom, boom. There's your transversal. And they said angle 1, this angle right here, 105 degrees. Angle 1 is 105 degrees. So, blow it up a little. 105 degrees, and that's angle 1. We need to figure out what's the measure of angle 2. So, remember, inform what type of line. What type of line is being formed here? That's a
I'm just getting battery dead.
I put that one on my desk, and then you get a different one. All right, so we have a 105-degree angle here.
They're a linear pair.
It's a linear pair. And what do we know about linear pairs?
They're the same line inside.
Well, they're they're on the same line, but what else do we know about a linear pair?
They're also supplementary.
Also supplementary, that means they have to add up to how many degrees?
180.
Yeah. So ladies and gentlemen, anytime you have a linear pair, angle 1 plus angle 2 adds up to 180 degrees. I think some of us were writing 190, some of us thought 90, some of us thought 200. Linear pair, angle 1 plus angle 2 add up to 180 degrees. Do we have an angle 1 measurement?
Yes.
How much?
105.
105. 105 plus angle 2 is going to give us 180. So what do we have to do with the 105 and the 180? Are we adding or subtracting them? Subtract. So it's going to be 180 minus 105. And what do you get? 75. Very good. It's going to be 75. And this is the key fact. I'm going to tell you, you're going to get a problem similar to this, along with what we're going to talk about next. So I would definitely mark this one as something you're going to see something very similar on your actual test. Because this idea is going to help us with something else. I think the next couple problems, if memory serves me right. All right. Questions on the linear pair deal? Angle 275. All right. So given angle 1 was 105 degrees. So we're going to go back So go back to 7A. So angle 1. So I know it's a little difficult being that on the previous page, you were told angle 1 was 105 degrees. We need to figure out now, since angle 1 is 105 degrees, well, we also know what was the measure of angle 2. Given the previous problem, what was angle 2's measure? Angle 2 was 75 degrees. All right, now, this question is asking, in this diagram, which angle besides angle 1 will also be 105 degrees? So remember, given our angle relationships as well. Then there was also one other method I told you that could have worked. Say it again.
The Charlie Brown method.
Charlie Brown method, because what type of shirt does Charlie Brown always wear? Zigzag. Oops, this may not work the best, but so anybody, so yeah, the Charlie Brown method. That's what I call it. He wears the zigzag t-shirt. So therefore, we go in a zigzag. So if we go zigzag from angle 1, what other angles are we going to touch? We go zigzag.
3.
Touch angle 3. So what else? 5, 7. There you go. It's going to be 3, 5, 7. So in this case, it's going to be all the odd number angles. But beware, your figure may not necessarily be all. They may change these numbers up a little bit, so I'll give you a heads up. But the zigzag method, aka Charlie Brown method, because of its zigzag t-shirt. That's how you can determine. Once you get the first 2 angles, you have the rest. And I think a similar thing is going to be said for the next problem, if memory serves. So the next problem, I think, is going to be the same idea, but the only difference is rather than angle 1,
No, 2.
angle 2. So we're going to copy this whole thing, basically. We'll morph angle 2 onto the next problem. Okay, questions before we go to the next problem? So angle 2 is 75 degrees. Again, think about our buddy Charlie Brown here. So besides angle 2, what other angles are going to have that 75-degree measurement? Okay. What else? Yup. And very good. 4, 6, 8. Gonna go zigzag. There we go. There you go. That was a Charlie Brown t-shirt. All right, questions on this problem? Okay. All right. This is where all of the beginning, the types of the relationships that we have between our angles are now going to come into play. Alternate interior, alternate exterior, corresponding, linear pair, exterior, interior, consecutive, and vertical. All those ideas are going to come back to us. Start with this problem. Okay, look at this first problem here. Notice the two angles that are indicated. Well, right away, the first part of this problem is what type of relationship is between these two angles. Look where they are. So you have to ask yourself, are they opposite side or same side? Say again? They're going to be in the end consecutive interior because you're right, Howard. Because they're on the same side and they're inside. So very good. They're consecutive interior angles. Now, since they're consecutive interior angles, and we're probably going to emphasize this a little more in the next question, what do we know about the relationship between those two angles? It's a consecutive interior.
They add up to 8.
Very good. Add up to 180. So these two angles are going to add up to 180. That's automatic. These two angles right here. Add them up to 180. 2x plus 4, 12x plus 8, 180. Okay, because we're going to talk about that in a minute. So I just want everybody to know this. Going to the next problem, that's exactly what we're going to do. So, given what Jason said, which equation, so we're on the next page. We're on the next page now, given what Jason said, which equation are we going to use out of the two, the top or the bottom?
Bottom.
Bottom, you have to use the bottom. Use that bottom equation. So, now, given that bottom equation, what's always the next thing we need to do?
Solve for x.
What's that? You have to solve for x, so yeah, you have to combine your x's. So I want you all, let me make that a little bigger. I want you to work on that equation. So write it down. And then from there, solve for the x. That's your next step. So I'll give you a couple minutes to try that as I update attendance. Okay, so we have so the value of x we all said was 12. All right. Make sure. So this is for anybody who's not sure why. Well, this is your setup. Notice our x's are on the same side.
Combine like terms.
Yup. So it's just like $12 in one pocket, $2 in another pocket, 14 total dollars. And then 4 cents in one pocket, 8 cents in another. I know not too many of us carry pocket change anymore, but just an idea. And then it adds up to 180. So yeah, you have to combine like terms. combined like terms, CLT. And then if we were to solve this equation, what's our first step here? What do we have to
Subtract 12 from both sides.
do it? Yup, you haven't done so. You get 14x equals, and then what's our other step, last step here?
Divide 14 by both sides.
Yep, divide 14 on both sides, very good. And then 168 divided by 14 is 12. Excelente. Oops. So x equals 12 is our response. All right. So far questions with this problem. You have x equals 12. You're going to use that x equals 12, I believe, if memory serves me, for the next, I think on the next problem. We will have two different angle measures here. So if we plug in the x equals 12, remember you have to do it for both now. I will show you. X is 12. Okay. So plug in the x equals 12 into both expressions. I think they were just testing to make sure the bells and everything are working. All right, sorry about that. Okay, plug in x equals 12 for both expressions. Who could tell us what we have?
So for 2x plus 4, we got 28.
Okay. Jason said 28 for the top angle. Agree or disagree with Jason? Agree? Who's not sure? Be honest. Top angle, he said 28. 2 times 12 plus 4. Agree with the 28 there, Valerie? Okay. What about the bottom one?
152.
152. We agree with Alex on the 152 for the bottom one.
Yes.
Because what must the two numbers add up to be?
180.
They have to add up to 180. Now this one, side choice would have fooled you. Bottom one, 144 and 24 don't add up to 180, so you knew right away this one's out of the game. So it would have been down to these two, but once you get this first number, then you knew, okay, it has to be 28. 152 is the only other number such that add them up to get 180. So that's our key number here. Good. Okay, questions? All right. The next one's going to be similar. So you will get a problem like this, the consecutive interior. I'm telling you that right now. And then you may get another one of this type, but you may not have to do all the necessary steps. I might just say, what's the relationship? Solve for the x. And then for the other type of problem we're going to have, given we have parallel lines, relationship between the two angles. So, in this case, what type of relationship is taking place between these two angles?
Alternate interior angle.
Say it again, Alex.
Alternate interior angle.
Very good. These are alternate interiors. These are both inside, opposite. Inside and opposite. So if we have that, then what do we know about their relationship? Their alternate interior angles. What will the relationship between the two angles be? Who remembers? Alternate interior.
They add up to 180.
Not necessarily. Not alternate interiors.
Okay, so then they add up to 90.
They're not going to add up to 90 either. Oh no, in this case, I'm going to be careful when we solve for X. I'll be careful with this problem, but only because given this problem, we might have something else going on here. But the general relationship between alternate interior angles may not always add up to 180, it may not always add up to 90. But there's something else. Alternate interior angles. What is the relationship with alternate interior angles? They're always something. What type of relationship? It may not necessarily add up to 180 or 90, but there's always something.
Was it equal?
That's the one. They're congruent. They have equal measures. Alternate interior angles are always congruent. That's an always. Sometimes depending on the angle measure, because if it was 45 and 45, they may add up to 90. Or if it's 90 and 90, they may add up to 180. But that's sometimes. But what's always with alternate interior angles, they're always, always, always congruent. That's the one. I'm going to go to the next slide in a second. Yeah, alternate interior angles, always, always congruent. Okay, questions on this problem? 'Cause that's going to be the key. So alternate interior. Now, even though I don't think I featured this on this particular test, but I may bring up something else, like another type of angle relationship. So that's, when I was saying there may be times where I've added information to your packet with the listening. There's going to be another problem I'm going to add to this. I thought it was on a test, but it wasn't. All right. So, what will be the equation? So they're congruent. These two angles are always congruent. Which equation must we use? Top one, you're right in. Gotta use the top. 5x minus 10, 4x plus 10. That's the one we have to use. All right. We're going to use this equation to help us solve the next problem. We're going to solve for x. I'll let you all try to solve for x on your own. So try that. Okay. I'll let you try that for a moment. Solve for the x. Basically, you're using this equation in the next problem. I'll give you the first hint. X's are on opposite sides. However, if you do this problem, it's actually not that bad. It's only going to be 2 steps at most. Be careful. Be careful with that one. What's the opposite of? Write it underneath. Don't write it underneath. What's the opposite of this one? So right, plus 10 underneath. Plus 10 underneath. Right, plus 10 over here too. So over here, so plus 10's on. Right side equals 10. Be careful. What's the opposite? Opposite of negative 10. Opposite. That's going to change your answer. Okay. Finish solving for x here. Did you work? Yeah. You gotta add the 2. Okay. Okay, I'd like to have a lot of us in this first step here. Five x minus 4x is, well, how many x's would be left? We start with 5, but we take away 4. How many are left?
1.
Just 1. 1x. Don't have the 1, no worries. 2. X minus 10 is positive 10 or just plus 10 or 10. Well, you can put the plus sign. You don't need it. You can have it. Now here's the next part. Here's where some of us made a major mistake. What's the opposite of minus 10?
Plus 10.
A lot of us put minus 10 twice. And that's how we wound up with that 0. But it's not gonna be 0. What's 10 plus 10?
20.
20.
This is gonna be 20. Okay. Equal sign, if you need to, set it up. But when you take an entire term, cross that equal sign line, you change that sign. So that minus 10, taking it over to the other side, you add 10. So x will be 20. All right. Questions on this problem? Now, next part. Basically, x is 20. Well, it should not be x. It's not going to be x equals. So we plug in x is 20 for either angle. Either angle. So x is 20, plug it into either first angle and the second angle. What will we get? We'll get 90. 5 times 20 minus 10, 4. 4 times 20 plus 2, you get 90. Going to get 90 at this point. Okay, questions? All right. What I'm going to do is go to the back. I'm going to do one more, but we're going to have it written on the back because those linear equation problems, you know, like slope, all that fun stuff, we're not going to touch. So like 12, 13, 14, 15, 16, we're not going to touch those. So you might as well just put X's the rest of the way. You're not going to worry about that.
So it's like cross off plus 19.
So yeah, cross the rest of what was printed out. I'm not gonna have you do that. So basically, yeah, you can cross out this entire page. Cross this one out too. So linear equations are going to be off the table. I'm not going to put them in. However, on the bottom of this very last page, we're going to do another problem. I do want you to do the following. I'm going to draw this diagram. So let's see what problem that was. Oh, that was not, okay, we're gonna, oh, I guess, okay, we'll make this problem 10. Since 10 and 11 will skip, this is gonna be problem 10. This is gonna be a different problem. So you're gonna write this one down. What else? hold on. Yeah, this is gonna work. This is your problem number 10. So it's gonna be, here's your new diagram for number 10. So get ready. It's 6x minus 13. It's this angle here. I'm just gonna shade in which two angles. 3x plus 14. Those are our two angles. That's our diagram. Now, given this problem, what you're going to do is the following. First off, what's the relationship here? We have those two angles. I know my drawing's not the best, but those two angles in those two spots. What type of a relationship do we have here between these two angles?
Alternate exterior.
Alternate exterior. All right, Zoe, Valerie, did you two get that? Well, yeah, that's what she said. It's alternate exterior. Number B. They're alternate exterior angles. What else do we know? If they're alternate exterior and they're separated by parallel lines.
They add up to
No, we would have to do it like that. We would have to lay it out like that.
What do you mean by like that?
6x minus 13 equals 3x plus 14.
Okay, so 6x minus 13, Catherine, you're saying is equal to 3x plus 14.
Yeah.
Okay, that's our equation. I'll agree with you on that part. Say again?
they're just congruent then.
They're congruent. Alternate exterior. Then the next question, congruent or add up to 180?
Congruent.
Congruent.
That's the other question. So that's the second question. They're congruent. Don't necessarily add up to 180. Since they're congruent, you set them equal to each other. Okay, now can we solve for x for this problem?
Yes.
Yes.
All right, so we're going to solve for x. So have you tried that?
Yes. So we're gonna subtract 3x from both sides.
Okay, so try that. That's your first step. And then from there, maybe I'll try to rest on your own. Give you a couple minutes. So you solve for the x, yep. Here's your first step. All right, actually, we'll knock it out.
So after that,
So what's 6x minus 3x?
3,
3 what?
3x
Minus 13.
minus 13 equals plus 13.
Good. Next.
So what we're gonna do next is we're gonna add 13 both sides.
Yes.
And we should
Then you
get
get 3x equals 27, and then you divide both of them by 3,
Okay, so
And then you
3x is 27.
and then you get x equals 9.
Right. Divide both sides by 3. X 9. Now, you have x equals 9. What's the one other thing you might be able to do after you get your x value?
plug them
I'll
in.
plug it into the equation.
Plug them in.
Either just to 1. Or if you
You
want.
can do either one, yeah? But yeah, good habit, plug them in. You plug them in. Then part D, plug in.
I got 41.
Okay, because then 6 times 9. Minus 13. With 3 times 9. Equals 14 in both cases, you get 41.
And just to add on, the other angle would have been 139.
Yup. So yeah, if this angle was 41, then the linear pair would be 139. Very good. Well done. Because in the end, the linear pair adds up to 180. The consecutive interior adds up to 180. Okay. I think we have time for two. All right, the only other thing I want to do real quick, on the very bottom, because I think the question now comes down to if they're congruent or add up to 180. That's, I think, the one final question. And it looks like I think we're getting it, but I just want to do like one or two quick little drawings. I'm just going to ask. Congruent or add to 180. And then that's going to be it. It should only take like a couple minutes. And then projects, if you want to work on them, give you about 20 minutes. So real quick, when they're congruent, or add to 180. So when they're congruent, that's when, for instance, you have your alternate exterior. Or you have alternate interior. Well, actually, let me do that on a different diagram. So congruent, that's an alternate, so alternate exterior angles are going to be congruent. Or alternate interiors are going to be congruent as well. Another case, oh, no. vertical. And then last but not least, like I'm missing one. Alternate exterior, alternate interior. Vertical. Oh, what other one? You get to the C, same spot. They are. Get to the C. Not gonna.
Corresponding.
Corresponding. And then the add up to 180, you have it in two cases. You were about to say it the first time. That's the executive interior. Good. And the other case would be when you have a what pair. You have a, into an L, blank pair.
Linear pair.
Linear pair. All right. Okay. So that's what's going on. Your consecutive interior or your linear pair. That's when you add up to 180. Okay. So that's basically Unit 2 in a nutshell. When you have consecutive interior angles, linear pair, alternate interior, alternate exterior, corresponding vertical. That tells us when they're either congruent or add up to 180. That's what we have going on. All right, here's what I'm going to do. For the rest of this period, you have the following. I'm going to go back up to the beginning. You can either work on your project, which if you need to do, I'd work on that first. If you're 100% complete with your project and you don't have any questions, if you want to start looking at the Unit 3 stuff on your own, which some of you might still have from earlier this quarter, you can do that. I have extra copies of the Unit 3 review if you need it. You need one? Okay. We'll probably do the Unit 3 review on Friday. Maybe Unit 3 and 4, depending on what's going on. So that's going to be all the new stuff for the rest of the period today. So you could either work on Unit 3 review or project. Project is in Schoology. Remember, project is a second quarter test grade. So you have about 15 minutes. If you have any questions about the project, these next 15 minutes are a very good time for you to ask. So that's what's going to be going on for the rest of this period.